Hello, everyone. Thanks for watching this video. This video is the instruction video about installing the SMAX 2018 August version in your Linux environment with a demo size. This video is customized for beginners. As our customers complains this installation documents are too long to read. And sometimes customer met a lot of problems or system down because of wrong configuration during the installation. So we think it might be helpful to present an instruction video to guide customers to install this product step by step. Now, here we go. Let's have a quick look for the agenda of this video here. This agenda briefly shows the roadmap for this whole installation process. And then, this video will illustrate all necessary steps for each installation phase. The first step is to enable your Docker Hub account, as it will be used to download all required images for SMAX from Docker Hub. After this step, please take your time to check hardware resources before other steps, including Linux version, CPU, memory and disk space. Here is an example of 3 machines. One is worked as the master, and the other 2 are used as workers. Different master and workers pairs can support the different size of SMAX. So if you want to have a much larger size SMAX or more powerful one, please go to our official documents to get detailed information about the hardware matrix. Now, back to how to have a hardware check for these 3 machines. This video just take an example for one machine. You shall check information in all masters and workers. Firstly, bear in your mind, please keep these 3 machines have the same operating system. We officially support the CentOS and Red Hat with their recent versions. As for checking the system OS version, you can go to the Linux terminal and get its system release info by typing this below command. Now, you can see the release system info for this demo machine is CentOS 7.4. So very lucky. Secondly, we shall check its CPU info. So you can get all detailed CPU information by typing this below command. Here, this is the processor ID, which is 7. It means this machine has an 8-core CPU. Further see, the core mode is E5 with more 2.6 GHz working frequency, which is very powerful. Thirdly, besides the CPU info, we shouldn't miss to check its memory info. So you can get the memo information by this below command. Normally, we just need to check its total memory and calculate it into the gigabytes. This one goes to 32, which is good. The last thing about its hardware resources item is the disk space. You can type this below command to get all disk information in this machine. Here, feel free to use this alternative command to check your machine's disk space. Beside all above hardware information, please make sure each of these 3 machines has a static IP address and all machines are in the same subnet. And don't forget to check these machines have the internet access. Let's move to the next step, time synchronization of these 3 machines. This step is very important as the same time can locate the logs with timestamps faster. And find out the root cause why this issue happened or why systems fell down at this time. Here is an example of using the Chrony in master. The Chrony is a popular time synchronization application. Will have a time synchronization among these machines. Now back to the Linux terminal. All commands will be displayed here to install Chrony and do the right configuration for it. This below command is used to check required libs and software have been installed in this machine. Of course, you can use this command to check other libs or software. If the output of this command is null, unfortunately, it means you need to install it. Otherwise, it will output the package name and its version code. Here, let us check if Chrony is installed here or not. Bad news. It returns null, so we need extra command to install it. The installation is very simple. Just typing this below command, and the Linux would automatically install the kernel in your machine. Now, let's use the check command again. Good. You can see the kernel has been installed in this machine. Let's continue to do the configuration for it. First thing is to create a drift file, and just using this below command. It will create the drift file in this path. By this below command, it's easy to find a right drift file has been created. Then we shall write stuff in kernel config file. For your convenience, please use this below command to configure this config file. Generally, for this config file we only need to define the NFS server and its drift file path. After the configuration, we need to type below two commands to enable and start the kernel in this machine. And you can use the command of systemctl status kernel to double check the kernel is in the normal status. Now just type this below command to synchronize time between this machine's time with NFS server time. After finishing this step, you need to restart the kernel and check the server time synchronization in this machine by this following command. The command seems that we have made the system time rightly aligned with the NFS server. Please run the below command to check if the kernel has the normal status. And then move to the next step of hardware time synchronization with this following command. And after this command, you can compare the output of hardware time and date time by typing this below command. You better check these times has been already synchronized with the time of your Windows system time, which you can see as the standard time. Now, you need to do the same stuff about kernel in all machines. The next step is to configure the installation permission for a sudo user for the master and all workers. Here we have a very detailed documentation illustrating how to configure installation permission for a sudo user. And please follow up steps displayed in the video or in the official document. The next step is very easy, just make sure the temp folder under the Linux root path on each machine, because the temp folder is a temporary folder we are using to store all temporary files, including Kubernetes installation files and various logs generated during the whole installation process. Here strongly recommend to set this folder as the type 7 permission on both the master node and worker nodes. We shall not miss to configure the firewall in these three machines. Because, the master and workers will share the mutual resource, and the master will assign the different tasks to each worker node. So it needs to ensure they can network communicate with each other. Here, feel free to use the below commands to configure the firewall in this machine. As for more details, please take a reference to the official docs. Now, let us move to the stage of NFS server host installation and configuration. NFS is the short name of the network file system. In our products, we use NFS server to be part of the persistent volume in our Kubernetes system. Here are the instructions to configure the NFS step by step in this example machine. Firstly, we need to install two packages, RPC bind and NFS utils. Please follow up the below commands to check whether two packages have been installed, and use the yum command to install them if the machine has not installed them yet. Now we need to enable and start RPC bind and NFS server in this machine by below commands. And then use this below command to check their running status. Good. Both are in the normal running status. Secondly, we need to create the directories list in this machine. You can copy the directories list from our documentations to the NFS installed machine. Then we need to add user ID and group ID in the Linux. Here please feel free to follow up this video to double check the user ID and group ID has been added in this machine. After creating the user and group, please copy commands from our docs to change the owner of each directory path that you have already created. Thirdly, we need to export the NFS directories by adding the following line for each of them in the export file under the path of /etc. And then run two below commands to check NFS server has correctly exported and normally mounted. Good news here. All preparation works have been done. Now let's enter into the official installation stage. Firstly, we need to install the CDF. The CDF is infrastructure base for installing the suite. So you cannot install the suite without the entire CDF installed in this cluster environment. We both support DNS and non-DNS environment. As for the non-DNS environment, you need to edit the host file in the /etc path. You need to write the master IP and master FQDN in this file. And then you can use these two commands to verify the FQDN and IP for this machine has been paired. Then, we need to download the CDF zip and CDF metadata file both in the temp folder. And then unzip the CDF package. Then we shall enter into this CDF folder. And you can run this below command to start the installation. And please be careful about the absolute path of metadata imported in this command. This installation will first have a pre-check. The installation will not continue if there are any failed items in this pre-checklist. See. There are some failed items in this checklist. They need to be fixed one by one according to the error messages. It is about the Linux swap. Here you can use the below command and check its swap total value is not 0 to verify the swap has been enabled. If the swap is off, you can use command swap on-8 to turn it on. The swap needs a special clarification here, although the pre-check suggests customer to close the swap. But we officially suggest customer to open the swap and edit the install properties file to pass the pre-check. Please follow the below steps. Let us open the install properties file and get rid of the hash mark before fail_swap_on and put the false value in it. Hold on, we also need to change the Docker HTTP proxy and Docker HTTPS proxy and save the file. Now, let us run the command again. It seems pre-check has been passed, and then input Y to continue the installation. During the installation, the system will firstly request you to set a password for the admin account, which will be used to log in the installation portal. Please follow the credentials rules. After the right credentials inputting, the installation will begin and the system will output all installation logs in the screen. It will take a few moments. Let us return back when the installation is finished. Good news now, the CDF is installed in the master now, and then we will install CDF parts and workers as well. And the Kubernetes home path is generally in here, /opt/Kubernetes. And the next step will be logging the installation portal. But for the non-DNS environment, please follow up these below steps before logging the portal. Firstly, you need to go the Kubernetes kubedns hosts folder in the CFG folder. And we shall copy the host files from /etc path to here. Secondly, we need to enter the objectives folder in the path of Kubernetes and edit the kubedns YAML file and check the IP and defqdn of the master has been wrote in the YAML file. Now, as my environment is the DNS based, so all DNS information has been wrote in this file already. If not, please follow the format and recreate this daemon set by below commands. Now, we can go to the installation portal by the URL provided in the end of CDF install output. And we suggest customer to log in our product by Chrome browser of its incognito mode. After loading for a while, the browser shows us the login page. Please use the credentials with username, admin and the password you set in the CDF installation and then log in. After successfully logging in, we can follow this step to install. Firstly, we need to set its release version, which 2018 August here, and click Next. And then we enter the page of End User License Agreement. You can click the URL to review agreements and privacy policy. Here by checking the checkboxes to agree with both documentations, and then click Next to go to the next step. Here we go to the Import Step of Capabilities page. In this page, you can choose which suite products to install in this CDF base. And you can click each item to see its brief description. For this video, we take the SMAX as an example. Of course, with more options selected, it will require more hardware resources to handle. And then Next. Now we move to Page of Database. The page will configure the external database for the CDF. Be clear. As for detailed configuration for PostgreSQL or Oracle, please have a review from our official documents. Also, the CDF internally builds an embedded PostgreSQL database, so this is optional. But for the production environment, we suggest customer to choose the external database. Here we choose the out-of-the-box PostgreSQL option and click Next, entering the next page. The next page is Connection page. This page will write the FQDN and port for this whole SMAX. Here as it deploys the single master, the external host name will directly take the host name of master as its value, and you should not change anything. And the next page is Master High Availability. This mode is designed for the high availability, which will involve 3 master nodes. As here we just use the single master node, so it is disabled by default. So please ignore it and click the Next to continue. Now we are in the page of Add Node. This page is for you to add worker nodes. And it is an option here allowing master to work as workers, which is a good way to save the hardware resource. Here please just click Yes to enable this option. And then click the Add button. The system will pop up a new small window. For the host field, you can input the IP address or FQDN. And then input the username and password for this machine. Also, you can input extra thin pools information. And then click Save button. The system will have another pre-check for this machine. Here, a failed item is captured. Let us fix the issue and then try again. Now see new check only shows the warning. You can choose the Ignore Warning button to continue the adding worker node. Now, we have successfully added a worker node. Let us do again to add another worker node. And then click Next to move forward. In the page of file storage, we can configure NFS path, mounting all NFS path to the real directory path in the NFS server. Let us take an example here. Please choose the self-hosted NFS, and then input the file server field with NFS server IP address. Then you can choose the exported path in the dropping list. And now click the Validate button to verify them. The system will return the success message. If not, the system will indicate the error and the hint. Please configure NFS for other exported path. After successfully configure all paths, click Next, and the system will pop up a confirmation windows to confirm this installation. Here by clicking Yes button. It will continue with the download parts, which indicating you how to download all required images for your chosen suite capacities. We support customer to download images with online or offline two methods. Firstly, we will go to the page Download Container Images. Please ignore it and go to the next page. In this offline download page, customer can go to the appointed path and download all images. But in this video, downloading online get displayed. Let us move to the next step. Now, we are in the page Start Downloading. Here we provide an URL link to download the script of download images. Please download it and copy it to your master node, prefer in the temp folder. Now we have the scripts in the master. Please unzip this package and start the download images scripts. This scripts will ask you to input your Docker Hub account information and suite information to download appointed version suite images. The download will take a while, let us return back when download is finished. Now all images are downloaded without any warnings. This is a good news. If you cannot download any images at first, it might be some missing configuration for the Docker HTTP proxy. Let us follow these steps to configure the proxy for the Docker. There is public images which you can try the proxy is rightly configured or not. After the right configuration, now we can run the download images again to download all images. After all images are downloaded, please go to the next page, and follow the below command to enter the appointed path to check all images have been truly downloaded and saved in this path. After the confirmation, please follow these below commands to go to the Kubernetes script path and run the upload images scripts, and this script will upload all images to the local registry of this Kubernetes environment. The upload process is also time-consuming. During the uploading, feel free to go to the page of Import Container MIGS page, and there is a Windows with a button Check Again, which will allow you to check missing images list. After all images are listed, now let us go to next page of deployment of infrastructure nodes, which will finish the installation in all added worker nodes. The next step is deployment of infrastructure services. It will set up basic service among masters and workers. If takes so long time in the page, you can click back to previous page and return to this page again to refresh this installation process. If this page hanging for a long time, feel free to go to the Linux terminal in the master and run the below command. It will show all Kubernetes pod status list. The ideal list is all pods have running status and all container are well set up, for example, 2/2 but not 1/2. If not, please fix it and then the installation can continue. The general issue are firewalled are not closed or registry proxy pods of workers are not set up. Please try to restart the Kubernetes to fix them. By now, CDF have been installed in both master and workers. And now we need to go to the suite installation parts. Click next to the Select Installation Type page. And please choose the Start a New Installation option and then move on. In the next step, it allows user to choose the suite size. The different size decides the largest number of concurrent end users. Here we just choose the demo size here and go to the next step. In the page Configure Database, you can configure the external database for suite. Currently we only support the PostgreSQL database. We just use the internal embedded database here and move on. In the page of Suite Admin Settings, it will allow you to set the passwords for the suite admin, which will use these credentials to log in the back office. After setting the passwords, we are here at the LDAP for CMDB authentication page. Here we still use the internal LDAP and go forward. After clicking Next, The system will notify to confirm to install the suite with this configuration sets. This page will show you the installation process. Feel free to go to the Linux terminal and run the below command to check all pod status. All fine pods status is ultimate sign for successful installation. Here are a few advanced commands to better monitor all pod status. After waiting for a while, now all pods are well installed, and the whole installation has been finished. The page will show you the URL link to get access the back office and management portal. Moreover, here are some suggestions for a special occasion where the installation portal are unexpectedly closed, and you cannot log in again, like below messages. We can get the process of the suite installation in the management portal. Please follow this step using the credential of username admin and password setting during the CDF installation. And go to the suite and then management. The page will show you suite installation status. In the end, thanks for watching this video. Please leave a like here or any comments if you met some problems during the installation. And we will further present more videos about the various SMA products here.